Today we are talking about a concept called antiderivatives. Somebody last class said, I've been antiderivatives all semester. I don't like derivatives. No, that's not what I mean by antiderivatives. It's not like anti-gun control or something like that. No, it's not like that. It's antiderivatives. Okay. The objective of what we're trying to learn to do today is simple. It is given the derivative. If I give you the derivative, find the original function. It's kind of like Jeopardy. For those of you in Physics C, it's the integral. Okay? But we're not going to write it that way. We're going to write it a little differently. No, we're doing it the short way. We are doing it the short way. Okay, there's actually two different ways to write it. Okay, we're doing just one way. We're not doing the integral symbol today. Okay, so first easy problem. The derivative of a function f prime of x is equal to 2. What is the original equation? So we write f of x equals 2x. But could it have been 2x plus 1? Could it have been 2x minus 5? Yes. It could have been 2x plus or minus any constant value, couldn't it? But I don't know which one it is. So what we do, every time we take an antiderivative, you always write a plus capital C at the end, because you don't know what that constant is.
Why do you do plus or minus?
Because plus and negative is the same thing.
Why not K?
No, it's just always been C. It's always C.
Why isn't it C in physics?
They do K in physics?
Yeah.
Really? Well, it's C in calculus. C for calculus. I did not know that. Interesting. Okay. Next problem. The derivative is x.
1/2 x.
How did you get 1/2 x squared?
How?
Yeah.
Because when you multiply, when you take the derivative, you do 2 times 1/2 and they'll equal 1.
Okay. Let me. Yes, you are right, but let me explain it a little bit slower for everybody else. If this is x, you know that this has got to be x squared. Do you agree with me? But if you just had x squared and you took the derivative of that, that would put you back at 2x. And I don't want 2x, I want x. So what needs to be in front of that squared in order to make it work so that when I bring the power down, I don't get a 2 there? I need to have a 1/2 right there, don't I? Jordan. I will be doing that in a minute. Yes. You were jumping ahead beautifully. So plus C right there. Always got to put a plus C on the end. Okay? What if, say, that was x to the 5th? Okay. If this was x to the 5th, what power will the original function be? 6. And that would be 1 over 6 in the front, right? So are you noticing something about the power and what goes in the front here? There's a pattern. That is really the power rule for antiderivatives that we're talking about. The power rule for and it says if f prime of x equals x to the n power, powers are usually n's, the only exception to the rule is that n cannot be -1. And I'll do an example of that in a little while as to why it cannot. The quick way to do it, okay, I'm going to leave some space. What power, if this is an n, what power will the original function have?
N minus 1.
N plus 1, because it goes up 1, remember? Okay, what goes in the front here? 1 over n or 1 over n plus 1? 1 over n plus 1 because it's the same as the power, right? Plus c. Okay? Now, possibly on the back of the worksheet, possibly in the book when you're doing problems like this, they may write it like this, where they take this x to the n plus 1, put it on top of the fraction, and write it as all one thing, x to the n plus 1 over n plus 1 plus c. And I'm going to write that in parentheses, because sometimes you'll see it that way. Some teachers really like teaching it that way. And it is kind of nice. The only time it's really not nice is what if the power started out, now I'm going to go ahead, I can squeeze that in here. What if it started out at 1/2? Okay. What power does 1/2 go up to? 3/2. Okay? Now, because this is a fraction, I really don't want to put 1 over 3/2 in the front. What fraction should that really be? It should be 2/3. It is the reciprocal of the power. That's what's really happening, because if you bring that down, the 2's will cancel, the 3's will cancel, leaving you the one that you need. Now, if you wrote it this way, you would have x to the 3/2 over 3/2. And I wouldn't want a fraction on the bottom of a fraction. That would be ugly. So I prefer writing it like this, plus c. I forgot my plus c right there. Shame on me. Put those plus c's in there. They will cost you. Tell you right now. All right. Any questions up to this point? Is this that? Are we a step down on difficulty now? Yes, ma'am.
Wait, okay, so I don't understand how you got the 2/3 because you said 1 over n plus 1.
Okay. 1 over 3/2. Agreed? That's another way to write it.
Okay.
X to the 3/2. Now, to clean that up, 1 divided by 3/2. How do you divide fractions?
Okay.
You flip the second and multiply.
Okay.
So that's an easier way to write it. So if you see it, instead of thinking 1 over that, think reciprocal. So if this is a 6, it's 1 over 6. If this is a 3/2, it's 2/3. Okay? All right. So let's practice a few of these. F prime of x equals 8x to the 9th plus 6x squared plus 5. Make this one a little bit harder. 8x to the 9th plus 6x squared plus 5. Now, this is the first time we've had any that started out with coefficients in front of our x's. Okay? So here is the way I recommend that you do this. I'm going to do it the long way at first, and I'm going to guess at least half of you eventually are going to be able to skip this step and go straight to the answer. Okay? So f of x equals. In antiderivatives, just like in derivatives, constants that are multiplied just sit there. So I'm going to write that 8, let it just sit there. Then afterwards, I'm going to put a parentheses, empty, write my x after that. If this is a power of 9, what was its power in the original function? 10. And what is the reciprocal of that to go in the parentheses? 1 over 10. That's what the parentheses is for the reciprocal. Plus, write down the 6, empty parentheses. What power should the x have on the second term? 3. What goes in the parentheses? 1/3. You follow me? Plus, what about the 5? What's the derivative, or what's the antiderivative of 5? 5x. Very good. Is that it? Plus c. Plus c. Very good. Now let's clean this up. So the original function will be 8 times 1/10. Reduce that. What's that going to be? 4/5. X to the 10th. Plus 6 times a third is 2x cubed. Plus 5x. Plus c. That's the answer. Okay? Questions? All right, it's your turn to try one. F prime of x equals 5x cubed minus 3x plus 7. Your turn. I'm going to come around the room and check these. 5x cubed minus 3x plus 7. You take the antiderivative.
I feel all what's that movie called? Chicken.
Okay. Next problem. Next problem. Now that you guys have got polynomials down, it's time to go to trig. I don't think my Physics C kids have done this yet. I figured. I think you stick with polynomials and that's it. Okay. Sine x plus secant squared x. Okay. Most people look at this and go, ooh, trig. But it's not that ew. It's not that ew. It's because it's really not that hard. If you know your trig derivatives. Some of you still haven't memorized them yet. Okay. Listen carefully. Shh. What is the antiderivative of sine? Negative cosine. Because if you had just written cosine, the derivative of cosine is negative sine, and I want a positive sign, so I need to put a negative there. Plus, what's the antiderivative of secant squared? Tangent, because the derivative of tangent is secant squared plus c. The end. Okay. Next page. Is everybody done with this? I'm going to throw another one in here. You don't see the top? No, you can't. Move down. Okay. F prime of x equals negative 2 over x to the third. Okay. There is no low D high or product rule or chain rule in antiderivatives, only a power rule. Okay? So, I can't do a low D high to get the answer to this. I have to do something else. Does anybody have an idea? Aaron, what do you think?
Right, put x in the on top.
So
negative 2x to the negative 3.
Exactly. Rewrite it to where it's negative 2x to the negative 3, then do it the way we have been doing it.
Adding and subtracting.
Okay, so now the original function, the negative 2 sits there, parentheses. What power does x become? Be careful. Negative 2. What goes in the parentheses? Negative 1/2 plus c. So the original function cleans up to be just x to the negative 2 plus c, or you can write it as 1 over x squared plus c. Either way. That answer on the back would probably be the second one. Yes?
Never mind. I figured that.
Okay. Are we good? Okay. I need to tell you something that I'm going to write down here. Answers with quote unquote plus C are called general solutions. There are two kinds of solutions to antiderivatives, general solutions and particular solutions. Okay? Because this is actually a whole family of functions right here. If you are given a point on f of x, so in other words, if they say this is the derivative and the original equation goes through this point, you can find what is called the particular solution. In other words, if it says find the particular solution, you're going to solve for C. You're actually going to find out what C is. All right. So I have an example like this that says the following. Find the particular solution. Hello. Thank you. Okay. The function f prime of x is 1 over x minus 4, and f of 5 is 3. Now, I don't remember if the worksheet uses this terminology. This point that they give you, they don't write it as an ordered pair. They usually write it like this. It's called an initial condition. An initial condition, as in other words, a starting point. Okay. Now, I am going to, on purpose, well, actually, let's do this. I want you to draw parentheses right here, and you'll see why in a minute. Okay? If we tackle this problem just like the one we just finished doing, kind of makes sense to do that, doesn't it? To bring it up. So you would say that f prime of x would be x minus 4 to the negative 1 power. Okay? That's not bad. But then when you try to take the derivative of this, or the antiderivative, you have x minus 4. What exponent does this become? 0. And what would have to go in the front? 1 over 0, which is undefined. So this does not work because I told you back over here, n cannot be negative 1. You remember that? Okay. So if you bring up the denominator and it gives you a power of negative 1, the power rule does not work. You cannot do it this way. And that's why I put it in parentheses, because it's actually the wrong way to do it. Because a lot of people are going to try. It doesn't work. So there is another way to. This right here is the derivative format of something else. Now, think for a minute to all of the different derivatives I've taught you. What kind of function starts out as a non-fraction, but when you take its derivative, it turns into a fraction? Natural log. Natural log is what we're looking at. Thank you. Tyler. Yeah. Okay. So what we have to do is to see that this is actually a natural log in disguise. This is the natural log of x minus 4. And that's not, there's no work to be done. That's just something you're going to have to see. Because think about it. What's the derivative of this? 1 over x minus 4. And on top you put the derivative of x minus 4, which is 1. Yes, sir?
So we could not have done that for the previous example, right?
Correct. Natural log only works when the n power is negative 1. Okay? Plus c. Throw that plus c on there. Okay, this is the general. Now what you do is you take the 5 and the 3, you substitute them in to solve for c. So f of x becomes the 3 equals the natural log of 5 minus 4 plus c. 3 equals the natural log of 1 plus c. And what is the natural log of 1?
0.
It is 0. So that's 0. So 3 equals c. So you just found c. Every time you're given an ordered pair, that will help you find c. So your final answer is f of x equals the natural log of x minus 4 plus 3. That's what I'm looking for. That is the particular solution.